This is mostly going to be a theory lecture where we're talking about classes and namespaces, and we'll use our own script, I think, as a talking point as well. So let's jump into our assets folder, right-click, create a folder that we will call scripts. Double-click on scripts, and within here, we're going to create a C# script. So right-click, create mono-behavior script, and we will call this movement with an uppercase M. Now let's double click on movement so that we can open that, make sure it's all looking good. Yes, it is. So in here, there's two very important concepts right in front of us, right in front of our face. One is namespaces. If you mouse over Unity Engine, it should say namespace. And the other is a class. If you mouse over movement, it will say class. What are these things? Namespaces essentially are containers for classes, and classes are essentially containers for variables and methods. And we can think of this from an analogy point of view as a bit like Russian nesting dolls. If you're not familiar with them, then this small doll fits in the larger doll, and the larger doll fits in the larger doll, and so on. And so you get to the point where you just have this one big doll, and it contains a whole bunch of little dolls inside it. And that's like the highest level is namespace. So for example, Unity Engine is a namespace, and contained within the Unity Engine namespace are a whole bunch of classes, including some classes that we might create ourselves. And then within our classes, we have methods. Methods are essentially saying, do this thing. What are the things we're doing? It's the statements, debug.log, or change the variable, or update this, or calculate that. So there's a grouping here. And essentially the reason we do this grouping is to keep things separate and to allow us to organize ourselves. What I mean by that is our code should be constructed on a need-to-know basis. What do you and don't you need to know? And the word we use is encapsulation. So where possible, we encapsulate our code, where we're putting a capsule around it, encapsulating, putting a capsule around our code so it only knows about itself. And the goal is to limit what the code can see, what it can change, and what it can be changed by for a whole bunch of reasons. But essentially, if we have things that can change other things without us realizing it or knowing about it or really wanting it to happen, then we can get bugs that we don't understand, and we can have things touching things that we didn't think they were touching. And we have, we called something move, but we've called it move in 3 different places. And every time we change move, it's changing move in all those 3 different places. So basically, we put a little capsule around, or a force shield around our code, so it can only be responsible for the things that we want it to be responsible for. So let's take an example. In our movement class that we just created, we might have a method in there where we say we want to update the player's speed. And if we have this philosophy of encapsulation, we say that only the movement class can alter the player's movement speed. Because if we had another class, for example, pickups, and in that pickup class, there was a way of having a speed boost. And then when you picked up that speed boost from within that other class, we're saying, okay, now make the player move quicker. Then we have this conflict because the movement class is saying, wait, I'm trying to tell the player to move at 10 units per second, but somewhere else is making it change to 20 units per second. I don't know. If we want to have pickups influence the speed, then we need to tell the movement class. We need to make a connection between the pickup class and the movement class, and then movement says, oh, okay, thanks for letting me know about that pickup. Movement, will take care of it from here, and I'll be the one who's actually updating the speed of the player. Also, this means that we typically aim for a class to do one main thing and not multiple things. So movement is just about movement. It's not movement and level loading. It's just movement. Level loading belongs in the level loading class. And all of this makes our code easier to read, easier to fix issues and bugs. And those things do come along, I promise you, even if we don't want them to. And easier to have multiple people work on a project, because you can work on the pickup class and I will work on the movement class and someone else will work on the enemy AI class, and they can be encapsulated. And if we need to make a connection between those classes, then we can explicitly say so and do so, rather than having all of this stuff in one big class, which is possible to do, but would be a big mess. Now, Unity comes already with a whole bunch of existing classes, and these classes contain a whole bunch of useful methods and variables. They're already created for us. They're good to go. It saves us a ton of time, and this is one of the main reasons we're using an engine, is because people have created this content already. And the note here is for us to access a class with all of its methods and variables and values, etc., we need to use the relevant namespace. And if we go have a look at the Unity documentation just briefly, and I've given you this link in the resources against this lecture, you can see that we've got Unity a whole bunch of things, accessibility.android.apple.ios, .search, .terrain tools. These are all namespaces, and within those namespaces, we access a whole bunch of classes, and within those classes, we have our methods, etc. So I've just randomly clicked on Unity.engine animations, which is the namespace, and then it's showing us here are the classes contained within that. So if we have a look at, again, just randomly, hopefully I click on something that makes sense. Muscle handle, that sounds weird. We'll click on that. Within here, handle for a muscle in the animation human stream. Cool. So there's a whole bunch of things that are already created we can access to get things to behave like muscles. Just another example down here within Unity Engine.scene management, which is a namespace, we have the scene manager class, and the scene manager class allows us to access certain static properties and static methods as well. So we can use a method which is get the active scene. We want to know what scene are we in at the moment. The scene is the way that we load from scene 1 to 2 to 3 to 4, and we might say, hey, what scene are we in now? Or load the next scene, etc. So this is all created within there. So if I wanted to be using these things, if I wanted to use load scene, then I actually need to specify that I'm using the scene management namespace. And so just a slightly different Unity document here. I'm looking at the scripting API. We'll be using the Unity engine.input system in this particular project because we want to be accessing the input actions and accessing ways for us to say, what button did the player press and what should we do now? And that's within this particular namespace. So if we go back over into our movement script, you can see we're using, that's a namespace, Unity engine. If I wanted to use the input system, we would type a new line. Let's do this together. Using Unity engine.input system. You can see it completes for a semicolon. Now we can access anything within that namespace. And why don't we just have all of the namespaces in here? Well, we don't need to access them all. We don't need Unity to be thinking about them. We don't need to accidentally access things or modify them or change them. So it's this principle of only do the things you need to do and only do the things you need to know about. It stops things bloating as well. And so as you can see, we're not yet doing anything. We're not using anything from the input system, so it's slightly grayed out, but we've popped it in there and we have access to it. That allows us to access the content within that namespace. So let's finish off the slides I've got here. What else have we got? So by accessing the class, we can access its content using the dot operator. For example, we use class name dot method name in terms of how we type things. And that's a really cool way of saying, let's just chuck something in here randomly. Debug, for example, is a class name. If I hit the dot operator, we've got a whole bunch of things we can do within debug, and log is one of the things that we can do, debug.log. So sometimes you can finish typing your class, hit the dot operator, and then just have a look around and see, what is it that we have access to? Or you can have a look at the Unity docs, or you can just remember these things over time. Oh, and while I'm thinking about it, one thing that you'll notice is that we've got movement.cs, which is a script, and we've got movement, which is a class, and they both had the same name, and it's automatically updated. When we make ourselves a new C# script in Unity, it automatically takes that name, the name of the file, and makes it the name of the class as well. So for that reason, you'll hear me using the words class and script interchangeably because they're kind of the same thing. Or let's go have a look at our movement script, or let's go have a look at our movement class, because typically we've got one class per script. It doesn't have to be that way. You can have multiple classes per script, but we tend to just have one class per script so that we know exactly what this thing's doing and it's just doing the one thing. So that was the point I was making just there. One class per script. Usually classes tend to be responsible for one thing. For example, just movement, or just collision handler, or just shooting, or just score, or just enemy AI. And in our case, it's going to be just movement, which is what we will be doing in here in upcoming lectures. We'll be getting the input system hooked up so that we can make our rocket move. That's all for this one. I'll see you in the next lecture.